ever wondered, why does a fire keep burning? Think about a simple candle. As long as the conditions around the flame allow it to burn, the candle continues burning. But when we cover the flame, it goes out. Something has changed. This simple example gives us the basic idea behind today's topic, the fire triangle. To understand how industrial fires start, we first need to understand what a fire needs to keep burning. Now imagine a worker performing welding or hot work in a factory. You can see sparks and intense heat. Nearby, there may be oily rags, solvents, packaging, or other combustible materials. But is a spark alone enough to create a fire? Not necessarily. For a fire to start and continue, other conditions must also be present. So let's look carefully at this workplace scene and identify those conditions. So, what does a fire actually need? It needs heat, fuel, and oxygen. These three elements form what we call the fire triangle. Heat provides the energy needed for ignition. Fuel provides something that can burn. And oxygen supports combustion. Remember the three words: heat, fuel, oxygen. What could provide enough heat to start a fire in a workplace? There are many possible sources: welding sparks, open flames, hot surfaces, electrical sparks, and friction can all provide heat capable of starting ignition under suitable conditions. For example, during welding, sparks can travel beyond the immediate work area and reach combustible material. So whenever you identify a heat or ignition source, ask yourself, what can it ignite? Now we have heat. But what does the heat actually burn? The answer is fuel. Fuel is simply a material that can burn when the required conditions are present. Fuel can be a solid, such as paper, wood, or plastic. It can be a liquid, such as oil, diesel, or solvent. And it can also be a gas, such as LPG or natural gas. So when you walk through a workplace, don't just look for ignition sources. Also look for materials that could burn. We have heat and we have fuel. But what helps the fire continue burning? The third element is oxygen. Ordinary fires commonly obtain oxygen from the surrounding air. Air contains approximately 21% oxygen, which is enough to support many combustion processes. That's why a flame can continue burning in an open environment where air is available. So now we have all three parts of the fire triangle: heat, fuel, and oxygen. Let's put the three elements together. First, we have heat, for example, a welding spark. Next, we have fuel, such as combustible or oily material nearby. And finally, we have oxygen from the surrounding air. When the required conditions are present together, combustion can start and continue. Heat plus fuel plus oxygen under suitable conditions creates the conditions for fire. Now it's your turn. Look at this hot work scene. Can you identify all three elements of the fire triangle? Let's check. The heat is coming from the welding spark. The fuel is the combustible or oily material nearby. And the oxygen is available from the surrounding air. If you identified all three, you've just applied the fire triangle to a real workplace situation. Now here's an important question. What happens if we remove just one element? What if there's fuel and oxygen, but no suitable heat? What if there is heat and oxygen, but no fuel? If the conditions required for ignition or continued combustion are not present, the fire cannot start or continue. And this gives us one of the most important ideas in fire safety. Control one of the necessary elements, and you can prevent or control the fire. So, How can we break the fire triangle? There are three basic approaches. First, remove or control the heat. Second, remove or isolate the fuel. Third, control the fire's access to oxygen or interrupt the combustion process. Different fire control methods work by controlling one or more of these conditions. What happens if we can remove enough heat from the fire? Cooling reduces the temperature of the burning material. When the temperature falls below the conditions needed to sustain combustion, the fire can be controlled. Water is commonly used for cooling certain fires involving ordinary combustible materials. But remember, water is not suitable for every type of fire. Always identify the fire hazard and follow the correct workplace firefighting procedure. What happens if we remove the material that is feeding the fire? If the fuel is safely removed or isolated, the fire loses the material it needs to continue burning. For example, where appropriate and safe, stopping a fuel supply or closing a fuel valve can reduce the amount of fuel available. Similarly, removing combustible materials away from a heat source can reduce the fire risk. The principle is simple: control the fuel, control the fire risk. What if we limit the fire's access to oxygen? A fire blanket can cover a suitable small fire and limit air access. Foam can form a blanket over suitable burning liquids and suppress flammable vapors. Carbon dioxide can displace or dilute oxygen around the flame. These methods interrupt the conditions needed to sustain combustion. But the correct method always depends on the type of fire. Never assume that one extinguishing method is suitable for every fire. Let's imagine a real workplace situation. A worker begins welding near an area where combustible material has not been removed. A spark travels away from the welding point and lands on the combustible material. A small flame develops. Now look at what we have. Heat from the welding operation, fuel from the combustible material, and oxygen from the surrounding air. The fire triangle is complete. The fire can now grow as long as those conditions remain available. The problem was not just the spark. The surrounding conditions allowed the fire to develop. Ask, now, what could we have done differently to prevent this fire? Before starting hot work, remove combustible materials from the area where practical. Control sparks with suitable barriers or spark guards. Maintain good housekeeping. Follow the required hot work permit process, keep suitable firefighting equipment ready, and inspect potential ignition sources. The goal is not to wait for a fire and then respond. The goal is to control the conditions before ignition occurs. Prevention starts before the fire. If you're a student, fresher, operator, or supervisor involved in hot work, here are 5 simple questions to ask before starting. Question 1. What is my ignition source? Question 2. What combustible material is nearby? Question 3. Can sparks travel to another area? Question 4. Is the area properly prepared? And question 5. Is the required fire protection available? These questions turn the fire triangle from a classroom concept into a practical workplace safety check. Let's see how well you can apply what you've learned. I'll give you 3 situations. Pause and answer before I reveal the solution. Question 1. A welding spark lands on cardboard. What is the heat source? Correct. The welding spark. Question 2. The cardboard catches fire. What is the fuel? Correct. The cardboard. Question 3. What supports the combustion? Correct. Oxygen in the surrounding air. If you can identify heat, fuel, and oxygen in a workplace situation, you can begin to recognize fire risks before they become incidents. Recall, before we finish, let's remember the three elements of the fire triangle: heat, fuel, oxygen. Under suitable conditions, these elements allow ordinary combustion to start and continue. Our job in workplace safety is to identify these conditions and control them before a fire develops. Control the heat. Control the fuel. Control the combustion environment. Prevent the fire. We've just understood the fire triangle. But fire safety is only one part of industrial safety. So, what should we learn next? Introducing the Industrial Safety Foundation video series by AG Academy, Industrial Safety and Manufacturing Excellence. Designed for students, freshers, supervisors, professionals, and safety enthusiasts. New videos every Monday and Friday. Subscribe to AG Academy and learn with us. Thank you for watching this video. Please like this video, share it with your colleagues, and subscribe to AG Academy for more videos. Stay safe, keep learning, and we'll see you in the next video. Learn, improve, excel.